Hello students. In today's video we are going to study check digit, which is an important verification technique and is frequently tested in examinations. A check digit is an extra digit added to the end of a number and is calculated using a mathematical rule. Its main purpose is to detect errors when data is entered or transferred from one system to another. It is very important to remember for the exam that check digit comes under verification, not validation. This means it does not check whether the data is sensible. Instead, it checks whether the data has been entered correctly without mistakes. Check digits are widely used in real-life systems. You can find them in barcodes, ISBN numbers of books, credit and debit card numbers, and bank account numbers. Whenever a long number is entered, the system recalculates the check digit to make sure no typing error has occurred. Now let us understand a check digit with a simple example. Suppose we are given a 6-digit number, 453621. To calculate the check digit, we follow these steps. Step 1. Starting from the left, we multiply the digits alternately by 1 and 3. Step 2. We add all the results together. Step 3. We find the number needed to make the total a multiple of 10. That number becomes the check digit. Step 4. The next multiple of 10 after 45 is 50. So the check digit is 5. This means the final number becomes 4536215. Now let us see how verification works. When this number is entered into a system, the computer separates the last digit, which is the check digit. It then recalculates the check digit using the first 6 digits. If the newly calculated digit matches the entered check digit, the number is accepted. If it does not match, the system shows an error message. This helps the system detect common errors, like a wrong digit or a missing digit. Now let us understand this check digit program using pseudocode. First, we declare our variables. Number is declared as a string because the input is taken digit by digit. Odd sum, even sum, total, check digit, and position are declared as integer variables. Next, we set odd sum and even sum to 0. These variables will store the sum of digits in odd positions and even positions. The program then asks the user to enter the number and stores it in the variable number. After that, a for loop starts. The loop runs from position 1 to the length of the number. Inside the loop, the program checks whether the position is odd or even. If the position is odd, the digit at that position is converted to an integer and added to odd sum. If the position is even, the digit is added to even sum. This continues until all digits of the number have been processed. Once the loop finishes, the program calculates the total. The sum of digits in odd positions is multiplied by 3, and then the even position sum is added. Next, the check digit is calculated by finding the remainder when the total is divided by 10. Finally, the program displays the check digit. This is how a check digit can be calculated using odd and even position sums. To conclude, a check digit is a very effective way to detect data entry errors. It is easy to implement and widely used in real-life systems. However, remember that a check digit can only detect errors. It cannot correct them, and it cannot detect every possible error.